John Many imparts making learning accessible.
In learning organic chemistry, there is the need to talk about nomenclature, in other words, how you will refer to molecules by their names. There are different ways of representing compounds. From general chemistry, you are probably familiar with some of these notations, but in organic chemistry, you would be dealing with very large molecules, and it would not be practical to write every atom. This is where the line notation comes in to simplify things for us. What you need to know about this notation is that every vertex and endpoint represents a carbon atom, but the hydrogen atoms are implied. That is to say, you should be able to tell the number of hydrogen atoms of each carbon atom without necessarily writing them out. Every alkane bears the suffix -ane. And a prefix which is determined by the number of carbons that are present in the parent molecule. For instance, 1 carbon is methane, 2 carbons is ethane, 3 carbons is propane, 4 carbons is butane, 5 carbons is pentane, etc. How can we name this alkane? First, we need to identify the number of carbons in the parent chain. It has 9 carbon atoms, hence it is called nonane. How would you name this alkane? To name this type of alkane, the first thing you do is to count the number of carbons in the parent chain, or the longest possible continuous chain. So, should we count it in this direction, or this direction? This branched group is a substituent and is known as methyl. It is an alkyl group consisting of only 1 carbon atom. Alkyl groups are named similar to that of alkanes. For instance, 1 carbon is methyl, 2 carbons is ethyl, 3 carbons is propyl. Well, you get the idea. When counting, it is advisable to count in such a way that the substituents have the lowest positions. 2 is less than 5, hence this is correct way to count it. We have a methyl on carbon 2, and the parent chain contains 6 carbon atoms, so the name of this alkane is 2-methylhexane. Note, you need to use a hyphen to separate a number from a word, and there is no space between methyl and the hexane. Here is a challenge for you. Identify the parent chain and number it in the direction that favors the substituents attached to it. You can pause the video to try. If you had this, then you are right. Well done. There is 1 methyl on position 2, and another one on position 5. There are 7 carbon atoms in the parent chain, therefore the name of this alkane is 2,5-dimethylheptane. Dimethyl because there are 2 different methyl groups. Note, 2 is di, 3 is tri, 4 is tetra, etc. Here is another example. So should we count in this direction or in this direction? Numbering from the right to left, there is an ethyl attached to the third carbon, and there is a methyl attached to the fifth carbon in the parent chain. Moreover, when we arrange the positions in ascending order, we get 35. However, numbering from the left to right, there is a methyl attached to the third carbon, and there is an ethyl attached to the fifth carbon in the parent chain. But when we arrange the positions in ascending order, we get 35 as the initial direction. When you get a problem like this case, you select the direction that favors alphabetical priority. Ethyl begins with the letter E and methyl begins with the letter M, and since E comes before M, it implies that this chain is the best option. Whenever you are dealing with multiple substituents, you write the substituents in alphabetical order. Therefore, the name of this alkane is 3-ethyl-5-methylheptane. With this example, should we count from the left to right? Or should we start from right to left? Numbering from the left to right, there is a methyl at position 2, and another methyl group is attached to carbon 3. Moreover, there is an ethyl at position 5. When we rearrange the positions in ascending order, we have 235. However, when we number from right to left, we have a methyl attached to carbon 6 and another methyl group is attached to carbon 5. In addition, there is an ethyl at position 3. Rearranging the positions in ascending order, we get 356. 235 is less than 356. Therefore, this is the right way to number the chain. Consequently, the name of this alkane is 5-ethyl, 2,3-dimethylheptane. Take note of the alphabetical order. I would like you to pause the video and try this example. I don't expect you to get it right, but I would be extremely impressed if you get it right. The solution is up next. If you tried this example, then you might have noticed that there are two potential parent chains. This chain contains 6 carbon atoms, and it has one branched alkyl group consisting of 3 carbons forming a V shape. It is commonly known as isopropyl, ISO, because it ends with a V shape consisting of 3 carbon atoms, and propyl because it is an alkyl chain containing 3 carbon atoms. Its IUPAC name is 1-methylethyl. The second potential parent chain is this chain. It has 6 carbon atoms as the previous chain. However, it has 2 substituents, an ethyl group and a methyl group. You must commit this to memory. Whenever you get a problem, as in this case, you select the chain with the most substituents. A parent chain with more straight alkyl groups is preferred to a parent chain containing branch alkyl groups. We only select a parent chain having branched alkyl groups when we have no other option but to choose it. Most students are likely to select the first chain as the parent chain. There is a methyl attached to carbon 2 and an ethyl attached to carbon 3. Therefore, the name of this alkane is 3-ethyl-2-methylhexane. This marks the end of today's lesson. Remember, practice makes perfect. See you in the next lesson. Goodbye.